Hello student, today we are going to see once again what is this Kelvin method in current electricity. Kelvin method, that is to determine unknown resistance. That is to determine the resistance of a galvanometer by using meter bridge. In last lecture we have studied with the help of Western meter bridge how can we obtain the value of unknown resistance. Today we are going to see what is this Kelvin method. When we say Kelvin method, that is this method is for determining the resistance of galvanometer. The galvanometer whose resistance G. Here this one is the galvanometer. Okay, whose resistance we are going to determine with the help of this Kelvin method. Galvanometer resistance is denoted by symbol G. It's connected in one gap, and a resistance, that means known resistance, is connected in another gap. See, the diagram is given in your book, page number C. That is 291. Observe and discuss. That is the Kelvin's method to determine the resistance of galvanometer on page number 219. Okay, then see working process. Okay, a suitable resistance is taken in the resistance box. First upon, you have to observe this diagram. Here, this one gap we have to given galvanometer. In another gap, we have given this resistance box from which we are going to take suitable resistance. And then here at this B point, here we attach the jockey. That means the connection of the jockey is given to this point B. And then this point A, that is the point on this potentiometer, or you can say this Western meter bridge. This A point is given to the positive terminal of the battery, and the negative terminal of the battery is given to the plug key K. And the remaining terminal of this plug key is given to the rheostat. Now see the symbol of rheostat here. Rheostat having 3 terminals. These 2 terminals are constant. Here this one terminal and this one terminal is constant. And this point C is indicated here. This terminal is variable terminal. Okay, the plug key is remaining terminal is given to the constant terminal of this rheostat, and this variable terminal is given to the point C. In this way, we have to join the circuit. And then what we are going to see, then the rheostat is adjusted. That means you have to take the suitable resistance here in this resistance box. And then you have to once again check the all connection. Okay, then take the suitable resistance from this resistance box and take this jockey in your hand and find out from this A to C the point at which this galvanometer show half deflection. Here I said half deflection, not null deflection. Okay, the rheostat is adjusted so to get a suitable deflection around 2/3 of the range. That means of this wire, you got this deflection at the 2/3, that means near about 50-50. Okay, then now the jockey is tapped at the different points of the wire and a point of contact D for which the galvanometer show no change in the deflection. That means the same deflection with or without contact between the point B. That means when we join this circuit, here when we join this circuit, this galvanometer show half deflection. Suppose the galvanometer having the range 30. Then when we join this all connection, at that time this galvanometer shows 15 reading. Okay, and when you take the suitable resistance from this resistance box and then touch this jockey on the different point of this potentiometer wire, the point at which, suppose here this point is D. At this point D, this galvanometer show again the same deflection as before. That means before starting the reading, it's showing the 15 deflection. At the same point, at the point D, it show the again same deflection, that is the half deflection. And the length of the bridge of wire between the point D and the left end of the wire is measured. The deflection along this G, that means from this A to D, which is the length among or between this G, it is called as the LG. That means the length along the galvanometer. and here this length along this resistance box, it is called as the LR. That means with the help of the meter scale, we have to take the reading or measure this distance A to D, and that distance is called as the LG, and then D to C, this distance is called as the LR. परत एकदा बघा, आपण ह्या गॅलोनामीटरचे जे काही आहे रेजिस्टन्स विथ द हेल्प ऑफ दिस केल्विन मेथड वी आर गोइंग टू फाइंड आउट. ओके, पहिल्या गॅप मध्ये आपल्याला गॅलोनामीटरला अटॅच करायचंय, दुसऱ्या गॅप मध्ये आपण रेजिस्टन्स बॉक्स देणार आहोत आणि इथे पॉझिटिव्ह जे टर्मिनल आहे बॅटरीचं ते ए पॉइंटला द्यायचंय, निगेटिव्ह टर्मिनल प्लग कीचं रिमेनिंग टर्मिनल तुम्ही रिओस्टॅटच्या कॉन्स्टंट टर्मिनलला देणार आहात, आणि सी जे टर्मिनल आहे दॅट इज द next terminal or the remaining terminal of this potentiometer wire, that is the C, is given to the variable terminal of the rheostat. अशा प्रकारे तुम्ही कनेक्शन जोडल्यानंतर तुम्हाला जॉकी जी आहे, ज्यावेळेस तुम्ही हे असं कनेक्शन जोडाल त्यावेळेस हा जो गॅलोनामीटर आहे तो तुम्हाला जर समजा त्याची रेंज 30 असेल, इट शो द हाफ डिफ्लेक्शन, दॅट मीन्स 15 व्हेन यू जॉईन दिस ऑल कनेक्शन. ओके, मग तुम्हाला काय करायचंय, जॉकी ही तुमच्या हातात घेणार आहात आणि ती ह्या ए पासून सी पर्यंतच्या वेगवेगळ्या ह्या पोटेन्शियोमीटरच्या वायरवरती टच करायची आहे, आणि ज्यावेळेस असा एक पॉइंट तुम्हाला मिळेल की ज्यावेळेस तो गॅलोनामीटर हा तुम्हाला परत एकदा जे आधीचं रिडिंग आहे 15 तेच दाखवेल, आणि त्यावेळेस तुम्हाला ए आणि डी मधलं अंतर मेजर करायचे. ऍट द सेम टाइम यू आर टू गोइंग टू मेजर द डिस्टन्स बिटवीन डी अँड सी. In this way, we are going to take the another reading for the another suitable resistance. You have to repeat this procedure 3 or 4 times to obtain this gallanometer's proper reading. That is the resistance of the gallanometer. Okay. After doing this process here, this RAD and this RBC, what is this? This is nothing but the resistance of the two parts of the wire, that is the AD and DC respectively. Since this G divided by R is equal to the resistance between them, that is the RAD divided by RBC. Again, what is this RAD? Which is equal to LG, that is the RBC is equal to LR. That means therefore G divided by R is equal to LG divided by LR. Here you have remembered the formula of Weston meter bridge, R1 divided by R2, which is equal to R3 divided by R4. Similar formula we got here, that is the G divided by R. What is this G? Resistance of the gallanometer. What is this R? R is the resistance which we have taken from that resistance box. What is this LG? LG is nothing but the length across this gallanometer. And what is this LR? LR is nothing but the length across this resistance box. Here we can write down this equation in another form also. That means we know that this LG plus LR is equal to 100 centimeter, because the potentiometer having the total length 100 centimeter. So this LG plus LR is equal to 100 centimeter. With the form of this IG, we can obtain this equation 100 minus LG. Okay, therefore using this another formula of this, that is the G divided by R, which is equal to IG divided by 100 minus IG. Here we want the equation for the resistance of the gallanometer. So rearranging the equation only for the gallanometer, resistance of the gallanometer. So these are taking on the another side. Therefore we got here the proper equation for the resistance of the gallanometer, that is G is equal to LG divided by 100 minus LG, that is nothing but LR. In the another terms, for the simplicity we have right here, that is the 100 minus IG. You can also write down that is LR. Okay, that is the length across the resistance box. Then this R. Using this formula, we can find out the value of this G. In this way, we see here the Kelvin's method. Now, what is this post office box? Another this concept is also related to this Weston meter bridge. Okay, here it consists of 3 arms, that is the P, Q and R. See, here this one A to B, this is P, this B to C, which is equal to Q. Another, this is given on the page number 220 on in your book. You can see this point number 2, that is the post office box. Okay, then the third arm, that is here this P, here this A to B, this is called as the P. Okay, then this B to C, it is called as the Q, And then this R is nothing but from this point to this point, this is called as the R. And the two arms, that is the P and Q contents, here you can here to take the 10 ohm, 100 ohm and 1000, which is given, these keys are given on that post office box. The third arm, that is this arm, is connected. This third arm contains resistance of 1 ohm to 5000 ohm. Okay, and then unknown resistance, here this unknown resistance is given here, the unknown resistance X from the fourth resistance, and here this K1 and K2, here is given this K1 and K2 key. These are nothing but the arrangement of the post office box. Again, here we are going to find out the resistance of the unknown resistance with the help of the three known values, and with the help of these three known values we can find out the fourth value of the resistance. Here the resistance in the arms P and Q are fixed to desired ratio, and then the resistance in the R is adjusted so that the galvanometer shows no deflection, that is the zero deflection. That means you have to take this ratio A P as Q, which is constant, and you have to adjust this R in a such a way that again the ratio of X divided by R is same. So that adjusting these values, you can find out this value of R. The resistance in the arm R is adjusted so that the galvanometer show no deflection. Now the bridge is balanced, and with the help of this we can take the formula, that is the X is equal to this RQ divided by P, where this P and Q are fixed resistance, that means this constant resistance, and they having the same ratio in the ratio arms, and R is adjustable. That is you can say this is the resistance box, okay, which we can change with the as the ratio of this PQ changes, you can change this R and see the value of this X. In this way, R is an adjustable, that is the known resistance, and if L is the length of the wire and R is the radius, then using the formula of the specific resistance of the material of the here, the wire is given, that is the rho is equal to, this is the value of X, that is the unknown resistance, and having the pi R square divided by L. In this way, we can find out first upon the X, that is the unknown resistance, and then with the help of the length L of the wire and radius, we can find out the specific resistance, that is specific resistance is equal to X area A, here the area, here pi R square, and per unit length, that is the capital L. In this way, with the help of this post office box, which is depends upon again the phenomena of the Weston meter bridge, we first find out the value of X, and then with the help of this value of X, we can find out the specific resistance of that wire. In this way, in the first session of this chapter, we have completed the applications which is depends on the Weston meter bridge. Now move towards in this chapter, that is the next article of this chapter is the potentiometer, and this is the most important concept of this chapter, because all the 12th standard practicals in electricity practicals totally depends upon this phenomena or this potentiometer. So first upon, each and every student must know what is this potentiometer and what is the principle of this potentiometer. This is very basic concept of this electricity chapter, current electricity chapter. Here you have to concentrate on this diagram. This is nothing but the diagram of the potentiometer. With the help of this basic diagram, we are going to find out what is the principle of this potentiometer. Okay, a potentiometer consists of a long wire. First of all, what is the basic? That is the potentiometer wire consists of long wire, conducting wire. Okay. Then suppose that conducting wire having the length L and resistance R, having uniform cross-sectional area A. In a short, we have given all information about that long wire. म्हणजे AB ही एक लॉंग कंडक्टिंग वायर आहे की ज्याची लेंथ L इतकी आहे आणि रेजिस्टन्स हा R इतका आहे आणि त्याचा क्रॉस सेक्शनल एरिया जो आहे हा A इतका आहे. In a first sentence we have given each and every information about that wire. That means that long wire is AB, having the length L, having the resistance R, and having the cross sectional area A. Now with the help of this basic information we are going to see what is the principle of this potentiometer. A cell, that is the EMF, that is the, here we can say this E, here the epsilon, but in your book this indication or the symbol of this EMF is given in the terms of epsilon. Okay, so here I use the word epsilon. A cell of EMF epsilon having the internal resistance R is connected across AB. See, this is the resistance which is connected here. This having the internal resistance R, and this one is the cell, that is the battery, you can say. Current, now with the help of the basic formula of the current, that is the I is equal to, when the internal resistance is given, then the formula is I is equal to E divided R, that is the resistance of this wire here. From where we take this R is nothing but the resistance of that wire, so R. And how this R here? Because of this internal resistance of this resistance is R. So capital R plus internal, that is the small r. So the equation I is equal to E divided by capital R plus small r. Now we have the basic formula for the potential difference across the AB. Therefore, the potential difference across the AB, which is given by the symbol VAB. What is the long form of this VAB? VAB is nothing but the potential difference across the wire A to B, that is AB, which is equal to IR. Here I is the current which is flowing through the wire and R is the resistance of the wire. So we have the formula for I. Here I have given in a red, blue ink here this value of I, that is the here this E divided by R plus R. So this E divided R plus R, again R as it is. Therefore VAB is equal to this E R divided by capital R plus small r. Therefore the potential difference per unit length. Okay, therefore VAB divided by L. Again similarly we are having the formula for VAB is equal to epsilon R divided by, you can say epsilon or E. But the meaning is that is the EMF. Okay, therefore epsilon R divided by R plus small r. Therefore again we are just taking the potential difference per unit length, so we are dividing by the L. Therefore the potential difference between A and C. Similarly, this potential difference between the A and C, that means the another short length here we have taken from this A to B. This is the total length capital L. Again we are going to take the another point between this A and B, that is called point C, and the distance between them is, that is the small l. Therefore this VAC is equal to KL. Why this KL? Because from this formula we can say that this value of E remain constant, R constant, and therefore this formula is, that is the directly proportional to the length across it. Therefore this VAC is equal to K into L. That is this potential difference across this wire, that means this AC is directly proportional to the length L. That means, once again see what is the principle of the potentiometer. The potential drop between the 2 points of the wire is directly proportional to the length between that 2 points. Once again I repeat here, what is the principle of the potentiometer? That is the potential difference across the 2 points is directly proportional to the length between that 2 points. म्हणजे दोन पॉइंट मधला जो काही पोटेन्शियल डिफरन्स आहे हा त्याच्या लेंथच्या कसा असतो, डायरेक्टली प्रोपोर्शनल असतो. दॅट इज द VAC डायरेक्टली प्रोपोर्शनल टू द स्मॉल l. Similarly VAB directly proportional to this, that is the capital L. Here this VAB as a long remains constant. That means this terms VAB is constant here. VAB divided by L remain constant, and this VAB divided by L is known as a potential gradient along the AB, and it is denoted by the K, and therefore potential difference can be gradient can be defined as the potential difference per unit length. In this way, thus the potential difference between the 2 points on the wire is directly proportional to the length of the wire between them, provided the wire is uniform cross-sectional, the current through the wire is same, and the temperature of the wire remains constant. Now see what is the uses of this potentiometer. First upon, we are going to see the use of this potentiometer wire, that is to compare the EMF of the cell. And we have performed one experiment in our practical, that is the E1 divided by E2. Therefore, use of potentiometer. Here this circuit each and every time remain constant, because this circuit is nothing but the circuit of the potentiometer. That is this A to B. This is potentiometer. Here the potentiometer circuit is set up by connecting a battery E with a K key and rheostat such that point A is at a higher potential than the point B. Now, instead of this rheostat here, you can use the resistance box also. Here, this A to B, this is the potentiometer. Okay, here this is not having the value of 100 centimeter. This is having in our practical purpose when we take this potentiometer to compare the EMF. At that time, we have to take this 400 centimeter wire. That means A to B having the distance 400 centimeter. Here, we are going to compare the two cells. Suppose this one E1 and suppose this is E2. And the all positive terminal of these both cells are given to point E. Then again the point of the positive terminal of the battery is also given to the point A. See, at the terminal of the A of the potentiometer wire, all positive terminal of the cells and this battery is given. म्हणजे या ए ह्या ठिकाणी बॅटरीचा पॉझिटिव्ह टर्मिनल आणि तुम्ही जे दोन सेल की ज्यांचे ईएमएफ तुम्हाला कंपेअर करायचे आहे त्या दोघांचंही पॉझिटिव्ह टर्मिनल हे ए पॉइंटला द्यायचंय. ओके, देन निगेटिव्ह टर्मिनल अगेन गिवन टू द प्लग की के, देन रिमेनिंग टर्मिनल ऑफ द प्लग की इज गिवन टू द constant terminal of the rheostat, and variable terminal is and every time is given to the end point of the potentiometer wire. Again, see the remaining terminal of the here where we are going to join it, that is the negative terminal of both the cells are given to K1 and K2 here the back. Okay, and then the combined terminal is given to the galvanometer, and negative terminal of this galvanometer is given to the next terminal of this galvanometer is given to the jockey. Okay, all these setups we are going to see in our practical lab. When you come and see this circuit as it is in practical lab. Therefore, what we are going to do here, with the help of this potentiometer wire, we are going to compare this ratio E1 divided by E2. Okay, if you take this 3 here, if we take this E1 is 3 and E2 is 1.5, then we got the ratio, that is 3 divided by 1.5, that is the 2. This calculation we are going to perform. This is the theoretical, and we are going to see this practically with the help of the potentiometer principle. What is, once again here I tell you what is the principle of the potentiometer, that is the distance or the length across this AB is directly proportional to the potential difference, or in another word, the potential difference between the point A and B is directly proportional to its length. That means the length between them. Here, in this way, we have to connect the circuit and then see how to calculate this E1 divided by E2. First K is closed, because in first case, we are going to take this E1 only. In next case, we are going to take E2. Therefore, K is closed, and then K1 is closed and K2 is kept open. Why K1 is closed? Because we are going to take in circuit E1 first and then E2. Then you have to take the jockey in your hand and put this jockey on the different point of this potentiometer wire. and find out the point at which this jockey shows the null deflection, and measure the corresponding length on this AB at which this galvanometer show what? That is the null deflection, zero deflection. And then this, as per the principle of the potentiometer, this E1 equal to KL1. That is the proportionality. Then now we are taking the next EMF cell, that is the E2 in circuit, so that K1 is open, K2 is closed. And again you have to take the jockey in your hand and put this jockey on the different points of this AB and find out the point at which this galvanometer show the zero deflection. And again find out the length at which this galvanometer show the zero deflection or the null point, and measure that corresponding length. Therefore, E2 is equal to K into L2. Therefrom, this E1 divided by 2. Suppose this is equation number 1 and this is equation number 2. We want here the ratio. So, E1 divided by E2 is equal to KL1 divided by KL2. KK get cancelled, and therefore E1 divided by E2 is equal to L1 divided by L2. As first, I have told that if this E1 is equal to 3 and this 0.5, the ratio is theoretically 3 divided by 1.5 is equal to 2. The same ratio we obtain, that is the L1 divided by L2. And in this way, using the help of the principle of the potentiometer wire, we can easily compare the EMF of this two cell. And this is the first application of the potentiometer principle. Now next, see the next application, that is the sum and difference method. These all practicals we have completed in our practical sections here. This circuit is connected as shown in diagram. First upon which method is called as the sum method and which method is called as the difference method. Now in first comparing the EMF, which is called as the also called as the separate method. Okay. Now in this experiment or in this method, we are going to use the two cells simultaneously. In first case, in sum method, that means see how we connected in sum method. Suppose this is E1, that is this the positive terminal and this one is the negative terminal. Similarly, cell second, this is the positive terminal and this is the negative terminal. What happened in sum method? The negative terminal of the first cell is connected to the positive terminal of the first cell. This method is called as the sum method. ज्यावेळेस तुम्ही हे जे सर्किट जोडतात तेव्हा पहिल्या EMF किंवा बॅटरीचा जो निगेटिव्ह टर्मिनल आहे ते दुसऱ्या बॅटरीच्या पॉझिटिव्ह टर्मिनलला जर तुम्ही देत असाल तर त्याला काय म्हणायचं? सम मेथड. याच्या उलट जर तुम्ही पहिल्याचा निगेटिव्ह, पहिल्या सेलचा निगेटिव्ह ह्या दुसऱ्या सेलच्या निगेटिव्हला जर जोडत असाल, which is called as the difference method. In first session we are going to use the sum method. Then you have to connect the circuit as per the difference method and take the reading. Okay. When K1 and K3 are closed, the cell E1 and E2 are in the sum mode and null point is obtained using the jockey. And L1 be the length of the wire between the null point and the point A. Then this E1 plus E2 is equal to K1 K into L1. म्हणजे ज्यावेळेस तुम्ही सर्किट पहिलं जेव्हा जोडणार आहात इथे K1 and K3, आता इथे पॉझिटिव्ह टर्मिनल आणि याचं कुठलं टर्मिनल आहे? हे जे टर्मिनल आहे हे पॉझिटिव्ह. ज्यावेळेस तुम्ही हे 1 आणि 2 कनेक्ट करणार म्हणजे काय होणार आहे? कुठल्या मोड मध्ये येणार आहे? सम मेथडच्या. म्हणजे याचं पॉझिटिव्ह टर्मिनल, सी इन डायग्राम दिस निगेटिव्ह टर्मिनल अँड फर्स्ट वन सेकंड वन इज हॅव्हिंग द पॉझिटिव्ह टर्मिनल. So at that time the circuit is in a sum mode, sum method. Then you have to take the jockey in your hand and find out the point at which the jockey this galvanometer show the null deflection. That means again circuit diagram is same as before. Here again this A to B is the potentiometer. Positive terminal is given to the A, negative terminal plug key, and this one is the rheostat. One terminal of this plug key is given to the constant terminal of this rheostat and variable terminal is given to the point P. Again, only here we are going to use this E1 and E2 cells simultaneously. In first case, we are going to use in a sum method, and in second case, we are going to use in a difference method. When we connect this 1 and 2, that means sum method, and at that point, we got the equation that is the E1 plus E2. Why plus? Because we are using this combination, sum combination, that the negative terminal is given first cell's negative is given to the second cell positive. At that time, E1 plus E2 is equal to K into L1. This is equation number first. In second, we are going to join this in the form of, that is the positive negative terminal, and so E1 minus E2, which is again KL2, and therefore this E1 plus E2 divided by E1 minus E2, which is equal to L1 divided by L2. But we have again here comparing the E1 divided by E2, therefore minus plus, solving this equation. Similarly here, L1 plus L2 and L1 minus L2, similarly solving this equation, that is the Compimento and Dividendo method. Here we got E1 divided by E2 is equal to L1 plus L2 divided by L1 minus L2. In this way, this application of the potentiometer to find the sum and difference method. In this way, there is another method which is given in your book, that is to find the sum and difference method. Okay, now the next application, that is to find the internal resistance. Here, this one is the third application of this potentiometer, that is to find the internal resistance. Here, this small resistance here, we are going to find out this. Again, the same phenomena of the potentiometer we are going to use. There is little bit difference in the circuit arrangement only, but the procedure is same. A potentiometer wire AB is connected in series with cell E, as shown in diagram. Here, this series, this is called as the series combination, and the K1, that is the K1 and rheostat as shown in figure. Therefore, the cell E1, whose internal resistance R1 is to be determined, is connected to the potentiometer wire through a galvanometer G and the jockey. Here, this galvanometer G and this one is the jockey. Here, this R, again this A and B, this is nothing but the potentiometer. Each and every time, if you observe carefully, you have seen this A to B, this battery, plug key, and this rheostat. Each and every time these are remain constant. We are changing as per the demand this above circuits. Okay, sum and difference method, separate methods, and third one is, this is the internal resistance. Again, this one is the, here in this we are going to use the two cell. This one is the main battery, and here this cell. Okay, this one E, that is in series combination, we have given this resistance. A resistance box R is connected across the cell R1 through the K2. As this, as shown in the diagram, you have to build or connect the circuit and take the reading. Okay, the K1 is closed and K2 is open. Then you are going to take, that means throughout this A to B, we are going to take here null point, obtain L1. Therefore, the E1 is equal to K L1. Therefore, now both the keys K1 and K2 are closed. म्हणजे आता ज्यावेळेस आपण ह्या जे आहे सर्किट ते सगळं जॉईन केलं, त्यानंतर आपण काय करणार आहोत, ही जी K1 आहे, ही जी K1 आहे ती क्लोज करणार आहोत. ऍट दॅट टाइम ही K2 जी तुमची की आहे ती आपण काय करणार आहे की ज्याला अक्रॉस हा रेजिस्टन्स आहे ती आपण ओपन ठेवणार आहोत. सगळ्यात अगोदर आपण E1 चं काय करणार आहोत, जे काही अलॉंग दिस लेंथ जी आहे ते आपण फाइंड आउट करणार आहे. त्यामुळे E1 इज इक्वल टू KL1 हे फर्स्ट इक्वेशन. Now we are moving towards the internal resistance so that K1 and K2 both are closed. Now both the keys K1 and K2 are closed, and closed resistance R is selected from the resistance. First of all, we are going to find out this L1, and then as per our formula, therefore this K1 and K2 is closed. दोन्ही कीज आपण क्लोज केल्या आणि आता काय करणार आहोत, सुटेबल रेजिस्टन्स याच्यामधून रेजिस्टन्स बॉक्स मधनं घ्यायचं And take this jockey in your hand and put this jockey on the different points of this potentiometer wire and find out the point at which is a galvanometer show again the zero deflection. And repeat this for the 4 or 3 reading. Okay, in this way we are going to find out this. Just 1 minute. In this way, here the formula is E1 divided by V is equal to IR. Therefore, this IR is equal to this IR, that is the for V. Therefore, small IR divided by IR, that is V is equal to IR. Here this E1 is equal to, using the loop, that is the PQ STP. Therefore, Kirchhoff's voltage law, E1 is equal to IR plus, that is the small r, again this I plus R, and again V is equal to IR. Using this formula here, therefore this I get cancelled. Therefore, L1 divided by L2 is equal to this R, that is the capital R plus small r divided by R. If you take this R common, then finally this equation is small r is equal to capital R in bracket L1 divided by L2 minus 1. And this equation gives the internal resistance of the cell. In this way, we here find out the internal resistance using the principle of the potentiometer. Now next, okay, today we stop here. In next lecture, we are going to see what is this voltage divider and audio control, and then potentiometer as a sensor.